All right, 22. Hold on. I'm looking for my final answer.
Is it
Right here. 22 is 2x plus 1 over 3x plus 5. For 22. Now, look at my work. I use the box method. I know some of you use the grouping method or whatever. But whatever way, you need to factor. Okay, and again, how many of you are still struggling with that factoring, how to factor? Because go back to the February and you should be able to see, and hopefully you have decent notes on how to factor. And that's what you really should be reviewing. Okay? I hope everybody's okay with that. Because we're going to be doing a lot more factoring today. All right, so in this case, I factored it out. Was everybody okay with their factors? And the final answer was 2x plus 1 over 3x plus 5. Okay? Good? Okay, number 24. Answer. Again, these are just combining your exponents. And it was 4/7 x y to the 5th z to the 9th. You guys okay with this? Jackie? Okay. Anybody have a question on these? Are we good? Good to go? Talk to me.
Yes.
Say yes. Thank you. Sing to me. Say yes. Okay, moving on to number 26. 1 over x plus 1 times x minus 3. And if you're not getting them, just raise your hand. I'll show you the factors. This one is 26.
What was the answer to 26?
Yeah? We can, yes. That was part of yesterday's lesson. We talked about how you can, I know, watch the tape. Okay? We talked about that.
Wait, there wasn't a tape on that.
There wasn't, you're absolutely right. I have to post it. I'll post it tonight. I'll do both of them. I apologize. Okay? That was 26, and is that as far as you guys went? 28? 26. Do I have 28? I don't know if I have 28. I do not have 28. 26. 7. Oh, I do have 28. 28 is 1 over n plus 1 times n minus 3.
Well, that one is. The next one.
Okay, you getting these?
No. Go ahead.
Okay, so what, do you have any questions?
I don't have any specific questions. I just need
Okay,
26
so
and 28 the same thing.
26,
Answer.
I just looked past that, Cassie.
Yeah.
Okay. 26, yes, the answer was, only the variables were different. One was x plus 1 and the other one was n. Okay? Yes, no, maybe. Are we good? What is this all about? Factoring. Factor, factor, factor. And if you need help, come to the math lab. Okay? So, we're going to move on from there. That was 26, right? Okay, 28. Take out your notes, please. Okay, so guess what? We have now multiplied and divided rational expressions. What do you think we're going to do next?
Add.
Add and subtract. Okay, please do the first problem. So if I have 1/3 and 1/4, show me how you do that problem. You're writing, Michael, you're not talking, you're thinking quietly.
What if I can do it in my head?
Yeah.
Okay, just if you can do that in your, I'd like you to write it down, because I'd like you to be able to see the operation that you're doing. Okay, so, what did you find for the least common denominator? The least common denominator is 12, and what do you end up doing to the 1/3?
Multiplying it by 4.
You're multiplying it by 4/4, which is equal to 1. Okay, we're changing the way this number looks, and what are we doing here? Same deal. So when you think about it, what you learned in 5th or 6th grade, you are still using. Same concept, same idea. Looks a little bit differently, but the same concept.
Oh, I learned it differently back when we were in elementary school.
To add fractions?
Yeah,
How did you add fractions?
we did it so that you would put 12 underneath, and then the original
Not-
denominator was 3. 3 goes into 12 4 times the numerator is what goes on top.
Okay, but isn't it the same idea?
Yeah, I was just
Same concept. Okay. You ready? Let's try the first problem. Okay, so now you're going to find the least common denominator of 4/a² plus 3a and figure,
Can you just multiply?
okay? What do you think we're going to do? No, no,
Divide them.
no. Factor! You need to know how to factor! I know. How many times am I going to tell you? You need to factor. So, let's see what we have for the factors of a² plus 3a.
it would be a plus 2a, no, a plus 3a plus.
Okay, so can I factor it and say that this is equal to a times a plus 3? And are we good with saying we can pull out the a² and a minus 2? Right. We good?
So that's still not
Okay, so can we look at what they have as a common, do they have anything in common?
a.
They have a, okay? This one has 2 of them. How many does that one have? So if we wanted them to be the same, what would we have to do? We're going to have to multiply that one by a, okay? Let's look at, this one has a minus 2. Does that one?
No.
So what do you think we're going to have to multiply that side by? A minus 2. Just as up here, you looked at these, this has a 3, this one didn't, you multiplied this side by 3. This side had a 4, this side didn't have a 4, you multiplied that side by 4. So your goal is what?
Get them to be the same.
Get them to be the same. And that's what we're going to do right now. Okay? So I am going to multiply. This side needed another a and an a minus a 2, because that side had an a minus a 2. But I need to make sure that it equals 1. So if I multiply my denominator, what do I have to do to the numerator?
Multiply by the same.
Multiply it by the same thing. Okay?
So you just basically take out like anything they have in common and then multiply that by the others.
And you're gonna see what they don't have. Yes, you're right. You're breaking it down as much as possible. And then you're looking, what do I need to do to the 2 pieces to make them the same?
So that's why you're not multiplying a plus 3 by a squared, a minus 2?
That's right.
Take out the a.
That's right. And this one has an a squared, so I'm not gonna multiply this by a squared, but what doesn't it have?
An a minus.
A plus 3. So I'm going to multiply this side by a plus 3. So will they have a common denominator now?
So So you do the multiplication of.
Okay, hold on, I just wanna zoom out a little bit. Okay. So, what will I have? You need to be careful in your multiplication. I'm going to have 4a times a minus 2. Think about this, I had a times a, I have an a squared, this side has an a squared, this side had the a minus 2, and we added in that a plus 3. This side had the a squared, it had the a minus 2, and I had to add in the a plus 3 over the a plus 3.
So you don't have to simplify.
Wait.
further than that.
Yes.
I have a question. Why did you put on the one that you're multiplying to 4 over a times a plus 3, you put
Let
an
me go
a
back.
times a minus 2?
I'm gonna go back.
The other side there.
Let's go back, hold on a second. So I looked at these, I factored them. This one has an a squared in it, and this one doesn't. So I need to add another a on this side, so there comes my other a. This one has an a plus 3, but it doesn't have this a minus 2, so this side is also going to get multiplied by a minus 2. Okay. So now this one will have, what did I have here? So here's the a that I added, and here was the a minus 3. I think I was up to here. And so I have that a squared, they both have an a squared. And then I can multiply across, because I'm adding. So now I have a common denominator. Can I add?
Yes.
All right, so I did 4a times a is 4a squared. 4a times a minus 2 is a minus 8a. And 5a plus 15, combine like terms. So I have 4a squared minus 3a plus 15, and that's all over what? A squared over a minus 2 times a plus 3.
Now do you factor the top?
Yeah, can you leave that?
You add on the top now?
Yeah. Pardon
Do
me?
you
You have
factor
to
the
factor
top?
the other one?
I could try,
And then
and
could you
see-
take out some?
if I could. This particular problem, I don't think you can.
But could you on some?
You would, right?
Would that
But-
be the, yeah.
You would, but you're trying to find as much, you're pulling out as much as you can, which is why you're factoring in the first place, as opposed to doing it later on when you have a bigger number. It's kind of like this. Some of you, if I gave you this 17 over 14 times, let me see, 84 over, let me see, so 96. Some of you would plug in and do all the multiplication and get some big answer, and then you'd have to simplify. Whereas I would say, well, 1 over 2, and 7 goes into that how many times? So it goes 12 times, and 7 goes into this, doesn't, 7 times, let's make this 7. Would be 10. So do you see how here I'm trying to break my numbers down as low as possible before I do my multiplication, and I'm going to continue to do so before I do my multiplication so that I'm in simplest terms, as opposed to 7 times 84, 14 times 70, multiplying it and then trying to simplify. Okay? Want to try another one? Okay. Okay. Okay? Is this 2x plus 4 over x squared minus x? And that's minus x plus 4 over x cubed minus x. Okay, so what am I going to try to do? Step number 1, factor. Okay, and does anything jump out at you? let me see. Looks like, and I'm just trying to think how I went about doing this. Looks like I did the denominator first, so I was looking for x times x minus 1. And then here, I have x cubed, and I pulled out an x. And what do you see?
The same thing.
Difference of perfect squares.
Difference of perfect squares. Are you beginning to recognize those? The difference of perfect squares, because what does that mean to you? I can factor it out, and it hopefully will make things a little bit more convenient for me, because what do I see? If I can factor that out, does that side have an x minus 1? Yeah. Do I have to multiply this side? Do I have to multiply that side by an x minus 1? No. What am I going to have to multiply it by? Yeah, okay, so this is what I have. I'm going to zoom out, sorry. So I can see, just looking at my denominators, that is an x times x minus 1. This is, I have this, they both have this. What do I just have to multiply that side by? X plus 1. Okay, I'm just going to multiply that other side. Okay, so, all right, hold on, I'm going to zoom out. So I just need that. And so I just need to remember, do I have to do anything to this side then? No? Just have to multiply that side. And it becomes a little messy, because what do I now have in over here? I am multiplying two, what are these called? Two binomials. So I'm going to have x times x is what? 2x squared plus 4x plus 2x plus 4. And that's what? 2x squared plus 6x plus 4 minus x plus 4 over, and let me say minus, sorry, x